This is the video for 1.1 to 1.3. We're going to start with 1.1 functions. Most of this material should look familiar from Algebra 2. If you were in Pre-P, if you were in Core, you might have to learn some of this in and out. So we're going to start off with brackets, and brackets indicate less than or equal to, greater than or equal to. And in graphing notation form, when you graph when you graph a function, it's going to be a solid dot. If I have less than or greater than, like I do right here, that is going to be parentheses on whichever side has a less than or greater than, and that is an open circle. So next we're going to look at functions. A function is where there is a unique y for each x. So we're going to look at this graphically using tables, or instead of tables, we might look at coordinates too. And then we're going to look at it algebraically. So graphically, the thing that we need to look for is that it passes the vertical line test. So if I have a quadratic or a circle and I draw a vertical line through it, as long as it only touches in one place, it is a function. If it crosses it on two, then it's not. So this is not a function. If we're looking at coordinates, or tables, we don't want our x values to repeat. So you don't want your x values to repeat. So for example, if I have 1, 2, 1, 3, that one has my x coordinates, my 1 here and my 1 here, so that's a no. This is not a function if I have a graph through those points. If I have the coordinates 0, 2, 3, 5, 4, 5, say for example, when I look at those, I have a 0, I have a 3, and I have a 4. I don't really care what my y values are. So this one is a yes. Algebraically, you want to look for that you have no absolute value around a y or a y squared in the equation. That basically indicates that for each x you're going to have a plus or minus a y. Those are the big red flags for those. So for example, if you have x squared plus y squared equals 3, even if you don't know what the function looks like, since you have this square up here, this is not going to be a function. If I have, let's say, x squared plus 3x plus 5y equals 6, since I'm only dealing with one y here, I don't really care about my x's. As long as there's just one y here, this will be a function. Okay, part 3, we're going to find function values. So we have g of x equals x cubed plus 3, and I want to find g of 2. All this means is I basically have to take 2 and I have to plug it into x. So that should be familiar to you from Algebra 2. 2 cubed is 8. 8 plus 3 will give you 11. You're just doing some substitution. I'm going to do the same thing here. I'm going to take my x plus 2 and I'm going to plug it into where the x was. And so that whole entire thing is going to get substituted in there. That's x plus 2 cubed plus 3. This needs to be expanded out. And yes, I do expect you to expand it out and FOIL everything out. So we're going to do these two together first. This is x squared plus 4x plus 4. If you FOIL it out, times x plus 2 plus 3. This gives me, if I have enough room, let's see, x squared plus x cubed plus 2x squared plus 4x squared plus 8x plus 4x plus 8 plus r3. And I did that by doing x squared times x squared times 2. And then 4x times x, 4x times 2. 4 times x, 4 times 2. And then I'm adding 3. So once I combine my like terms, that is going to give me x cubed plus 6x squared plus 12x plus 11. Okay. Next, we're going to look at finding domains. This is section 4. We're going to find the implied domain, which is the set of all values for which a function is defined. So I have f of x equals 2 plus x over x squared minus 7x. When you have a rational function, remember that your denominator cannot equal 0. So when I'm trying to figure out what my domain is, the thing I need to think in my head is, what values can I exclude from your all real numbers, negative infinity to positive infinity. So here, the only two numbers that I can't have, or it might be more than two, are whatever will make my denominator 0. So if I factor out an x, yes, we will be doing a lot of factoring this year. We're going to factor out x, we get x minus 7 equals 0. So this is where our graph can't be equal to 0, so our x is not equal to 0, and x is not equal to 7. So I need to remove 0 and 7 from my all reals. That's going to give me negative infinity, skip over the 0, keep going to the 7, skip over the 7, and out to infinity. So I'm removing 0 and 7 from my all reals. Next one, I have f of t equals square root of t plus 5. So when you have square roots, you cannot have a negative number come out of a square root. So your t minus 5 has to be greater than or equal to 0. So if I kind of solve this way, that's giving me t minus 5 is greater than or equal to 0. So that means t is greater than or equal to 5, which means my domain is 5, including the 5 to infinity. And that's my domain for this one. So in our last one on C, I'm going to move this up because I need some space. I have f of t equals 1 over t squared minus 4. So we have a couple things. Remember, kind of similar to B, your t squared minus 4 has to be greater than 0. And since it's in the denominator, I can't have it equal to 0. I'm not going to put a less than or equal to. It's just going to be a less than. But there's a trick to this. So this factors to t minus 2, t plus 2, greater than 0. So when you solve inequalities, you're basically going to have to get what's called your critical points. So my critical points are t minus 2 equals 0, t plus 2 equals 0. So we're looking at 2 and negative 2. So I'm going to make them on a number line. And then we're going to check each area and see whether or not a number in this section will satisfy the function, a number in here will satisfy it, and a number in here will satisfy it. Before I do that, though, we know that since this is greater than, at negative 2 it's not going to satisfy it, and at 2 it's not going to satisfy it. So I'm going to check in here, for example, I'm going to check negative 3. So if I plug in negative 3 into my function, all we're looking for is that we're going to get a positive number underneath my square root. So when I do that, let me move this up a little more. When I do that, I get 1 over square root of 9 minus 4, 1 over square root of 5. So this part's okay. And it kind of makes sense if I do the one on the right and do 3. I'm also going to get 1 over square root of 5. So this side will be okay. Let's try, say for example, 0. If I plug in 0 into my function, going to get 1 over square root of negative 4, and you can't have negative 4 underneath a radical. So that part of my domain is not going to be included in my answer. So all I'm going to include is this area over here, up to but not including 2, and then starting with 2 and going up to including that area. So I'm going to go from negative infinity to negative 2, not include negative 2, skip over everything between negative 2 and 2, and then from 2 to infinity. That's going to be my domain. So you have to be careful when you have a radical in a denominator, like we do here. When you have inequalities, you're going to have to solve them and check them on a number line. Okay, last part of section 1.1 is piecewise functions. A piecewise function is a function that is defined by 2 or more functions. Think of it like 2 or more pieces. We'll graph it later, so right now we're just going to learn to evaluate them. So if I look at my function here, up here, okay, it shows that I have the function 2x squared plus 6x when my x is less than negative 4. So that means any number that's smaller than negative 4, but not including negative 4, you'll plug in any x value you plug into this function. If I have any x value between negative 4, including negative 4, or 12, including 12, we're going to plug those numbers into the second function. If my x value is bigger than 12, my answer is automatically going to be 14. So you're not going to have 3 separate answers. Your x value only fits in one of these domains. So for the first one, if I want to find f of 3, 3 falls into the second domain. So this one is going to go to that function. So this is going to be 6 minus 3 squared. That gives me 6 minus 9 is negative 3. The next one, negative 4, falls in, and if you look, you've got negative 4 here and negative 4 here. However, you want to look for the one that has the less than or equal to symbol, not the less than symbol. Less than means it's up to but not including that number, whereas this one means it's including it. So you're going to put this one into the second function as well. 6 minus. Another important thing to do is when you're plugging in a negative number, make sure that you put it in parentheses for your function. So this is 6 minus 16 gives me negative 10. The third one, 13, falls into the domain of the third function. And since there's no x value for me to plug anything in on this function, all that means is that my y value is just 14. It's that function. If I look at negative 6, my negative 6 falls within this first function. So I'm going to plug negative 6 into my function and simplify. So 2 times negative 6 squared is 36, plus negative 36 plus 4. This is 72. 72 minus 36 is 36. 36 plus 4 is going to give me 40. And that is the end of 1.1.